Well, now we need to turn our attention to a new definition. It's an important definition for us. It's going to be the idea of what do we mean when we say that a function is differentiable at a specific value. So let's read what we have here. A function f is differentiable at a value a if f prime of a exists. Okay, so when we say that a function is differentiable at a spot, we really just mean that you can take its derivative and you can plug in a value a and actually get an answer. That means, of course, that the slope of the tangent line can be found at that point. We could also say that if a function is differentiable on an open interval if it's differentiable at every number inside of an interval. So I could say a function is differentiable from 6 to 7. And that would just mean from every number in that range, I can always plug those numbers into the derivative and get a result. That is, I can always find a slope of a tangent line on the original graph for those numbers. Now, if you take a look at example 5, we can see how easy it is to actually use this piece of terminology. Notice here we're being asked to show that the function f of x, which equals the square root of x, is not differentiable at 0. Okay, so that would mean if it's not differentiable, that would mean that when I try to plug 0 into the derivative formula, I can't calculate a result. Now, we may recall that we actually already found the derivative of a function of the square root of x. We actually did that all the way back in example 1. And if you were to go back and take a look at it, you should be able to confirm that we ended up with the result of 1 over 2 square roots of x. So we should be able to immediately conclude that, wait a minute, plugging in 0 here would definitely be really bad. Notice that f prime of 0 is going to be 1 over 2 times the square root of 0, which would be 1 over 0, which is undefined. So f of x is not differentiable at x equals 0. It is differentiable in a lot of other spots. Anytime I could go to my derivative, plug in a number, and get back an answer, the function is differentiable. Notice, say 1. Is the function differentiable at 1? Yes, because when I plug in the number 1, I can get an answer back. I get back 1/2. Is the function differentiable at 2? Yes, because I can take 1 divided by 2 square root 2, and that is a number. I don't know what number it is. It's not a pretty number, but it is a number, so automatically differentiable. We could then actually state, although this is really extra, that f of x is differentiable on the interval from 0 to infinity. Notice that's really just stating ultimately the domain of the derivative, all of the numbers that I can plug in order to get results. So this is the meaning of the word differentiable. That's important to understand because we'll use this verbiage very, very often when describing functions. Sometimes we'll say that a function is different, or if a function is differentiable, then something else might also be true about it. And so the next theorem will actually give us an idea of a relationship between differentiability and continuity. But we'll talk about that in the next video.